We'll start with problem 38 from chapter 2. And the problem says, a car sitting at a red light begins to accelerate at 2 meters per second when the light turns green. It continues with this acceleration until it reaches a speed of 20 meters per second. It then travels at this speed for another few minutes. How far does the car travel in the first 30 seconds after the light turns green? So, as you see over here, there's a graph. This is a velocity versus time graph. Because it starts at rest, the velocity and time, obviously, both start at 0. You can see that over here in the given values list. So velocity not equals 0 meters per second, and then time, we can always assume it starts at 0. And it accelerates at 2 meters per second all the way until it reaches this point at 20, right? And we're going to mark this time as TA, the time that it is accelerating from 0 to TA. And then between, so the question is asking how far it has traveled within 30 seconds. So if you go over here to the graph of 30 seconds, then the time that it's traveling at constant velocity, we say is TV, and that's between TA and 30. So then if we want to continue our list of given values, you see the acceleration in the x direction is 2 meters per second squared until it reaches the final velocity. Then we see that, velocity sub x is the final velocity we see, and that's 20 meters per second. And like I said before, it's asking what distance it travels at time equals 30 seconds. So first we're going to calculate time over here, and we use this equation. All of the equations used are from the formula sheet, and they are in the same format that the formula sheet has them all in. So sometimes you'll see people say V sub F instead of V sub X. They're the same thing, it just means final velocity, and sometimes people will even just leave off that sub anything, and so they'll just leave it at V. And then over here, V naught, V sub 0x, sometimes people will say V sub 0. And this is the equation that we use, right? So to find time, we have the final velocity, we have the initial velocity, that's 0, right? We have acceleration and we need time, so we rearrange this equation over here, and this is what we're given. So velocity final minus velocity initial, all divided by the acceleration equals the time that it is accelerating. Do those calculations, input the values, and we find that it's 10 seconds. And then, we want to find TV as well, the time that it has constant velocity. And so we say, the classic 30 seconds equals TA plus TV. And then you find TV is 20 seconds. Next, we are figuring out the distance that it's traveled. Because there's a change in acceleration, a change in velocity, right? Both of those things. We have to calculate this in two different sections. So what we can do is, draw over here. Oops, that's not the right thing. Here we are. Oh, no, that didn't work either. Let's see here. All right. Right here. Assuming that this TA is, assuming that that's a straight up and down line. So first we calculate this distance traveled during the first part. So we use the distance equation, x equals x naught plus this equation here. And then because x is over here already in the correct place, we just input the values straight in. We find that during the first 10 seconds, it travels 100 meters. Over here, we're calculating the constant velocity distance. so to here, right? We use the same equation. For this, I set the initial distance to 0, and that's why you see this mark out here. And that just means that we are looking at the distance traveled between these two lines. If you want to, calculate the total distance here, you can set this point right here, the distance equal to 100 that we got from the accelerating number, and then you don't have to sum them at the end. But we find here, plug in all the numbers, it's 400 meters, and so then the x total is the sum of those two values, or if you used 100 meters here in the x naught category, then you'll just find the answer is 500 meters. So that's the first problem. Let's move on to the next problem. This is 54. And the problem says a rock is thrown vertically upward with a speed of 12 meters per second from the roof of a building that is 60 meters above the ground. So first we want to draw our graph, and I said before that you can draw the graph third. So what I said before was you write out the given values, you write out, and that would be here. You write out the desired values, and that would be here. And then you draw the graph, but you can also draw the graph first to help you visualize where everything is. So we see that this distance here is 60 meters, and so we set y equal to 60 meters, right? So this point here is where it's starting, and so that's going to be the initial y value. Now here we use y because we're going in the y-axis. Up above we used x because the car is going on the x-axis. Later on you'll see cannons that will go kind of in that motion, and you'll find you need to use x and y values. But so it's a good habit to use y and x in their respective axes whenever the question is just using one. But the equations from the formula sheet, they're all in x. You can just transfer all the x's to y's and you'll get the same equation that you can use if you use y. So the initial y position is 60 meters because the building is 60 meters tall. Initial velocity up here, 12 meters as we said, and it's positive because we're going up, and then we'll use all of the downward values as negative. You could reverse this and say that upwards is negative and downwards is positive, but it's just classic for people to say up is positive and down is negative. Then, it goes into the questions. A, in how many seconds after being thrown does the rock strike the ground? So t equals what? At y equals 0 meters, right? And then B, what is the speed of the rock just before it strikes the ground? That just means, at the time taken to do the whole thing. Then what's the velocity at the point that it hits the ground? Most of the questions will say just before it strikes the ground, what's the velocity or what's the speed, but it means, what's the speed when it hits the ground. And then it says assume free fall. That means that there's a force of gravity, and gravity, which you'll need to memorize in the y direction is negative, because it's going down, 9.8 meters per second squared. Bless me. And yes, so v at y equals 0 down here. So the final velocity is what? We can use this equation up here that we saw first. We can use this, the distance equation, but in that case, we'll have to use the quadratic formula to find out t. So instead, we're going to find velocity first using this equation. So, if we have this, what we're trying to find is Vy. So we have to rearrange the equation. It's easy for this one. You just take the square root of the right side, and then you've got Vy equals square root of V initial squared plus 2a times the change in y. That's the final y minus the initial y. Another way to write that is delta y, which is, oh, no, wrong again. Let's see. Here. Which is, the triangle, and then the y. Oh my. There we go. So that's the same thing here. Now that it's rearranged successfully, we put it all in, and then calculate it. It says 36.3 degrees meters per second. Sorry. But remember that it's going downwards, so we have to put that negative sign in. The calculator is not going to tell you it's negative because it's square root here. But you'll need to remember to put the negative sign there. Next, we use time using that, our found final velocity, using this equation here, and rearrange it to get time on one side. So I think we use this equation up above right here, and we rearranged it the same way here. So you should know how to do that. And then you put all of these lovely numbers in. You find it's 4.93 seconds. Now, if you get a negative number, there should be a point here. This is 9.8 here. If you get a negative number, you know that time cannot be negative, and so you've done something wrong. Usually it's just a sign error. Maybe you forgot this negative up here when you calculated the final velocity, but just be aware of that. So moving on to the final question. This is example 2.11 in the textbook, so it gives you the problem and it works out the problem. I'll run through it just so that y'all are familiar with all of the parts and understand how everything works fully. Yeah, let's just, okay, yeah, sounds good. All right, this problem, it says a bunch of stuff, and then it goes into the problem. The ball leaves your hand, suppose you throw a ball vertically upwards from a flat roof of a tall building. The ball leaves your hand at a point even with the roof railing with an upward velocity, so an initial velocity, of 15 meters per second. On its way back down, it just misses the railing. So it goes up and then down. Find A, the position and velocity of the ball at 1 second. So position and velocity at 1 second, and 4 seconds. So 4 second and 4 second. And it says the velocity of the ball when it is 5 meters above the railing. So velocity at 5 meters. And then the maximum height it reaches. And the time that it reaches that. Yeah, so y max, and then I put t max, and that just means t at y equals max. Something to remember is that these subscripts just tell you generally, it gives you a hint as to what the actual component is talking about, because there are multiple positions, right, over the course of this physics event, throwing the ball up. And so y sub 1 second, that just is going to mean, at 1 second, what is the position of y? So all of these subscripts are not necessarily conventional, but they can help you remember where everything goes and what each component actually is. So first, we're going to find the y positions, and we're going to find both of those. We'll find both of the velocities at 1 second and at 4 seconds. So up here, we see that the velocity at 1 second equals velocity initial plus acceleration times t. Oh, right over here. I forgot to say this. In the given values, right, they've only given us 3 things. We're assuming that it's a free fall, and so acceleration is a downward pull of 9.8 meters per second squared. We already know our initial velocity, and we assume that this position here that we're starting at is 0 meters. If they gave us the height of the building, we could say that we start at that number. Like up above, we were given 60 meters. But in this case, we don't have the height, so we start at 0. Okay, over here. Velocity, right. And so, you input all of the values here. And for the velocity at 1 second, it's positive 5.2 meters per second. You do the same thing with velocity at 4 seconds, and then you find that it's negative 24.2. Don't forget the negative signs and the positive signs. All right, so we've found velocities. Next, we find the y positions. We find the y positions, so the velocity, we use this equation here. And again, like I said before, what you want to do when finding out which equations to use, you're just looking at what you have, and now we have 2 extra values. We have the velocity at those positions. And so you add those into the givens list here. And then you're looking at the formula sheet, matching up which ones have only what you have plus what you need. And so here we've been given the final velocity, initial, acceleration, and y initial. So we want y at 1 second. Rearrange this equation as seen, and then input all of the values. You'll find that it is 10.1 meters. Do the exact same thing over here. Remember over here that the velocity final is squared. So this velocity we found for 4 seconds, it's not going to be negative anymore because it's the negative times the negative, which makes it positive. So what we're given is a negative 18.4, which means that it has gone below the surface, the roof of the building, which, do a sanity check. It makes sense because the velocity is also negative. Now the velocity could be negative and it could be above this, the roof of the building. But if the position is negative and the velocity is positive, when you're just throwing something off a roof of a building, that means it's going against gravity and you have a miracle. But in physics, I don't think miracles are allowed. So moving on to the velocity at 5 meters. So we use the same equation that we used just before, and we take 5 meters to be the given y instead, and then, do the same thing. Now, because you're taking the square root, you want to say that it's plus or minus the square root of this rearranged equation here. And then when you're inputting all of the values at the end, you make sure to indicate that it's plus or minus 11.3 meters per second. And that is because, 5 meters above the roof of the building, there's 2 points on this downward curve. You have it going up and you have it going down. Now, if you take any point on this up and down, then the velocity, the magnitude of the velocity is going to be the same. the only difference between the 2 points, the velocity at the 2 points, is the sign. But that's only if it is parallel to the ground, right? So that's something that you'll come to understand more and more as you do more of these problems. But you can just take it from me now and believe me. Otherwise, you can prove it yourself. Finally, we're going to look at the y value at the maximum. Now, once it gets to the top of this point and it changes directions, right? So first we are starting with a positive velocity, it goes to negative, it has to go to 0, and that's when the y is at the maximum height above the building. So at the y max, then you know that the v, the velocity, is 0. And so we take that as the given y final and input it into this equation. You know, we've used this a couple times now. And so we rearrange it again, get y max on its own, input all of the values again, and you'll get 11.5 meters. This one definitely has to be positive because it's going up above the building. And it is higher than at 1 second, so you know that at 1 second it is either on its way, at 1 second up above it said that it was over here 10.1 meters, and then this point, oh right, it was also still going up at 10.1 meters, which means it's not too far after 1 second that it reaches 11.5 meters. And we'll see that in our Tmax answer. So we use another equation, right? Same stuff. You're just plugging in equations, figuring out which values you have and which ones you can use in the formula sheet equations. So you rearrange again, make sure that all of your signs are correct, and then input the values, and you find out that it is almost 1 second. It's just a little bit higher than 1 second, 1.53. If you have any questions, feel free to message me on the group chat, or you can direct message me or email me. All of those work, and I hope you'll have a wonderful rest of the week and that y'all have enjoyed your snow day. Bye-bye.